yourself? Where from? Which grade are you in? Where are you from?
I'm going in the 6th grade, and I'm from San Diego.
Oh, okay, good, good. And Henry, can you open your camera? Show your face. I cannot see you. Henry, can you introduce yourself?
I'm going for 57, and I'm from New York.
Okay, good. And Jasmine,
I'm in middle school, and I'm in North Carolina.
can you make the camera a little bit lower? I cannot see you face. And Emilia.
Hello.
Can you open your camera?
Okay.
Can you introduce yourself? You mute yourself. Emilia, you mute.
Sorry, I was plugging in my webcam. Okay, so hi, I'm Emily.
Your camera is still not open.
I opened it.
Your camera is still not open, not show up.
I turned it
on. Oh
on.
yeah. Can you move the camera lower a little bit? I cannot see your face. Okay. Then can you introduce yourself?
I'm Emily. I'm 13, and I just got out of school like yesterday.
Okay. Which grade are you in?
I'm in 8th grade, and I'm going to 9th.
Oh, okay, good. Then now let's see, Michelle. Michelle, can you open your camera and introduce yourself?
Hi.
Michelle, have you opened your camera? You also mute yourself. Can you open your camera?
Hi.
Your camera is not open. Your camera.
My camera's open.
Your camera is not open.
It's open.
It's open? Okay, yeah. Can you introduce yourself? Oh, yeah.
I'm in 7th grade, and just got into summer break yesterday as well. And I'm going into 8th grade.
Oh, okay. Where are you from? New York?
No, Washington.
Oh, Washington. Okay. Good. And Royce, can you introduce yourself?
Hi, my name is Royce.
Can you open your camera? I cannot see you. Okay.
Hi, I'm Royce, and I'm from New York, and I'm in 8th grade. I'm going to 9th grade next year.
Okay, great. Okay, very good. So today, this is my first time for our geometry class. This class is very interesting, and also it's much different from the other math subject like algebra and arithmetic and geometry. That's two very different things compared with other subjects. One, it's ask you to prove, not only calculate. Another thing, they ask you to construct, to like build up how you do it. This is also much different with other subject. And also these two skills training will make you more logic. You know, we ask you to prove why, okay, how you can get that. So then you can become more logic. And another, we ask you to construct. So then make you can use your hand to think how you build this. Not only know how to calculate, how to prove, but you need to know how to build up. This is also very important for the a lot of career, like engineer, a lot of sub careers. So now let's review this book. I think this book probably is the best book in the world for geometry. I think this is the best book. So you can see in this book, we have totally 19, let's say, 19 chapters. Among these 19 chapters, first chapter we call what's the name. So that means we need to give you some definitions and the names we have to use in this subject. Otherwise, we'll show you example. You can see it's very difficult to communicate with each other. And second chapter, we will learn the angles. Okay, this is a very important subject, and also it's very basic. But then you can see some problems are also very challenging. This is angles. Third chapter, we will learn the congruent triangles. This is a most core subject in this geometry class, because here there's a lot of very important theorems you have to learn, and also it's very useful to solve a lot of problems. Then chapter 4, we will learn the perimeter and area. So this is help us to calculate the perimeter and area a lot of 2D, two-dimensional geometric shapes like triangle, quadrilateral, trapezoid, and parallelogram, and also like rhombus, a lot of shapes. And chapter 5, we will learn the similar triangles. Similar triangles, that means we don't care about the size, we only care about the shape. So if the two geometric figures there have the similar shape is same, but only its size may be different, and also like position or direction you put is different. But if you adjust their direction and position of these two figures, then you can see they have exact shape, but the size can be different. This kind of figures we call similar figures. For triangle, we call it similar triangles. Then chapter 6, we'll learn a special triangle called right triangles. That means we have angle equals 90 degrees. For this special triangles, there's a lot of really good characteristics, like parallelogram. That's very famous theorem that can use in a lot of area. We will learn this and also use this theorem to help us solve a lot of problems. And the number chapter 7, that's special parts of triangle. This chapter actually is the most challenging chapter in this book. And then we'll learn the we call that 3 centers of a triangle. Okay, that's like the intersection points of bisectors, intersection points of medians, intersection point of attitudes, and also we'll learn how to build this like bisectors, medians, attitude, and their intersection points. And chapter 8, we'll learn the quadrilaterals. Quadrilaterals, that means you have 4 sides. Then for the quadrilaterals, we have the trapezoid, parallelogram, rhombus, rectangles, squares. All these quadrilaterals, they have 4 sides. Then there's a lot of characteristics related to these shapes. We need to learn this kind of knowledges. And in chapter 9, that's polygons. Polygons, that means we have each sides, it's a line segment, but they enclose for a closed shape, all like triangles, quadrilaterals, pentagons, hexagons, all these belong to polygons. Okay, then we care about the angles in a polygon, and also like edges, angles, areas, parameters, and also how we can contribute to construct a regular polygon. We'll learn this. In chapter 10, we'll learn the geometric inequalities. This one looks like algebra, but actually this one we are learning geometry that's use I don't know, maybe most of you already know, in any triangle, the sum of any 2 sides is greater than the third side. And also the difference of any 2 sides is less than the third side. This one called geometric equality. Actually, this one has a very important application in many areas. And now in chapter 11, we'll learn circles. I think this one probably is the most beautiful theorems and problems in geometry. And a lot of very beautiful problems you can learn from this chapter. And we'll learn how to measure the arc, how to measure the angle of arc, length of arc, and circumference, and the area of the sector of the semicircle, full circle, and also a lot of problems related to the circles. And chapter 12, we continue learn the circles and angles. You know, a lot of angles combined with the circles. That's a lot of problems related to these figures. We also learn how to construct tangents. Tangent, that means a line intersect with like circle only at one point. Okay, that's called a tangent. And chapter 13, power of point. This also really, really beautiful. From one point, then start to intersect or tangent with a circle. Then you get a lot of geometric relationship between the segment start from this point to intersect with the circle, then also cross the circle. They have a lot of very beautiful relationship there. We can learn from this chapter. Then chapter 14, we'll learn the 3D dimension, 3D geometry. In here, you know, before that, what we learn is only like 1D, 2D. And this chapter, we learn the solids, like prisms, pyramid, polyhedral, okay? And chapter 15, we'll learn the curved surfaces like cylinders, cones, spheres, and all the character related this to these solids. In the chapter 16, we will learn the more things like translations, rotations, reflections, deletions. Okay, this one tell you how to translate a geometry shape to another shape, like by translations, rotated, reflection, and deletion. And in chapter 17, we will learn the analytic geometry. Analytic, that means algebra. Actually, that means we combine the algebra and the geometry together. Then that'll help us to build a bridge between the algebra and the geometry. By this way, they help us solve a lot of problems more convenient if you don't have this bridge. So then you can say, we will use algebra way to describe what is a line, what's a circles, and what is the basic analytic geometry problems, and also to proofs with analytic geometry, and the distance between a point and a line, and also learn the advanced analytic geometric problems. In chapter 18, we'll learn the trigonometry. Trigonometry, that's more useful in the physics and also the other subjects. So if you want to learn the physics, you have to learn the trigonometry first. Otherwise, you cannot handle the very basic physics problems. Because, like say, I can give you a very basic physics problem that usually they discuss. Suppose there's something put on this a tilt. Then this is if the mass of this box is m, then the gravity of that m times g, right? If this angle theta, then what is the component of this? This is called a normal force. So how you can calculate this normal force? You have to use trigonometry. So use mg, then times sin theta will give you this component. Use mg times cosine theta will give you the normal force. So if you don't know this trigonometry, it's really hard for you to deal with. This is a very basic classic Newton mechanics problems. When you learn the physics in the second chapter, you have to learn this one. So therefore, this is very important. You have to learn the trigonometry first. Then the last chapter will show you some tricks or strategies you can use to solve a lot of very difficult math problems in the geometry. That's one way. That's one trick called extra line. We also call this additional line. When you try to solve a geometric problem, a lot of times it's test you if you can find a good way to add an extra line in that figure. That will help you to solve the problem very easily. So then we'll teach you how to add an extra line. And another trick we call assigning variables. To solve the problem, you assign a variable to the problem that will help you become logic and help you make clearly the relationships between the variables. Then we show you how to prove. Okay, and this is the last chapter. I think in this book, you can say we'll learn a lot of good stuff. They will help you a lot to make you prepare to learn the more advanced subjects like physics and calculus, pre-calculus. So this is actually it's a very important subject, and also it's very unique. As what I said, one, it's emphasize proof, not only calculus. You know, in algebra, the most thing what we do is calculus, right? But in geometry, the most important thing is to prove. This is, I think, it's a very weak point for the students in United States. You know, in United States, most time they emphasize to calculate, right? A lot of students, even when they graduate from high school, they don't know how to prove. And this is we need to emphasize, make you to learn how to prove in this subject. And then another thing, to build, not only to understand, but you need to know how you can build that. In geometry, it's very important. We only allow you use 3 tools, okay? One is called a straight edge, okay? Straight edge. Straight edge, that means it's a similar like a ruler, but they don't have the scale, okay? Then I can show you, if you have everybody prepare a set of geometry 2 box, okay? You know, you see this one is a triangle, right? This one's a triangle. On this leg, you have 2 legs. One is and hypotenuse, right? In a triangle, these 2 sides we call the legs. Then you can see there's scales on these 2 legs. This one, if you have this scale, we call this one the ruler, okay? Because you can measure line segment, how long is that? Like 1 centimeter, 2 centimeters. This is called a ruler, okay? But then you notice for the third size, this one, hypotenuse, you can see there's no scale there. This one called straight edge, okay? So this tool will help you to draw a straight line, but it cannot help you to measure how long is that line segment, right? So in the geometry, we require you can only use straight edge, okay, to help you draw a straight line. You cannot use a ruler, okay? So that means you cannot measure the length of line segment, okay? The second tool we require you prepare that's called a compass. This one can help you to draw a circle, okay? Also can help you can use this one, measure, use this open, right? Let's say, because this different angle of the openness can help you actually measure how big is that openness. But you don't need to know that number, okay? Sometimes you just need to use this compass help you measure, okay, this line segment is equal my compass openness. Then I just move that measure to another location, then help me draw another line segment equals that line length of that line segment. But you don't know how long is that line segment, okay? So by use the compass can help you to measure the length of line segment, use this openness. Okay, you just know this this openness. Okay, is big like this, but you don't know how long is that, like 2 centimeters, 3 centimeters. You don't know that number. Okay, so this is the second tool we call the use compass. Then the third tool, definitely we'll use that a little bit. We call that protractor. That one, it help you to measure the angle. It's like this. Okay, but we only use this one a little bit. Okay, later we don't allow you use this one anymore. Okay, but in the only one chapter, that the angle chapter, then we like you use this one, measure the size of angle. Okay, this is the only 3 tools allow you use in the geometry. And definitely another one is pencil. Okay, or pen. When you draw a straight line, you not only have a straight edge, but you need to have another pencil or pen to help you draw that straight line, right? So you need a pencil. I suggest you use pencil. Okay, this one help you to can if you draw something wrong, then you can use rubber to remove that. Okay, if you use pen, it's hard for you to change it. So pencil and rubber, that's okay, but usually we don't count that. We only count these 3 as the tools you can use. And this one only use a little bit. Later, the most important 2 tools, that's straight edge and compass. A lot of times they tell you what is the exact tool you can use. They tell you that's a straight edge and a compass. Okay, so that's what I like to show you to in this subjects. So later, now we will start this subject. Okay. Then now let's start first chapter. First chapter, that's called what is the name? You know, let's say in the geometry, because that's very special. And let me ask a student help me read this paragraph. Let's say, Michelle, can you help me read this, start from here? Why names and symbols?
Why names and symbols? To convince you that names and symbols are useful, we will start at the end of the book instead of the beginning. Here's the final example problem in this book, written without any special symbols or name.
Continue read that.
Draw 3 points and connect each to the other to a straight path. Also draw the circle that passes through all 3 of these points. Then draw a line through one of those 3 points, such that the line goes inside the region you just formed and is equally close to 2 other straight paths you will form initially through this point. Draw the circle that goes through the one of your 3 first points you just drew a line through the point where this line hits the straight path that connects the other 2 of your first 3 points, and go through the point that is halfway between these 2 other points. Consider the 2 paths from the first. We drew the extra line through to the other 2 of our first 3 points. These paths hit our second circle before they hit these 2 other points. Show that the distance from where the circle hits these paths to the point where these paths and is the same for both guys.
Yeah, I don't know if the other people if they can understand this paragraph, but for me, I don't know how this paragraph talk about. It's very confusing, right? So the reason is they did not use any names or symbols at all. They just use a very basic English word to describe. This will make the complication in geometry is really, really hard. We cannot do this. If we do this, we cannot learn the geometry at all. It's very confusing. So that's the reason we need to define some names and symbols. Okay. Now let's see. First, the very basic geometry symbol, that's point. You can see here, point. We call this one point. That means only that the location, no others. Okay, they don't have size, they don't have the directions. Okay, they only show you the location. That's a point. Okay, so then for the point, usually we use a capital P to represent. Okay, then this is a point. Okay, on point is very, very boring. You cannot go anywhere. Okay, if you move a little bit to any direction, then you fall from that point. So point is only a location, has no size, no directions. Okay, now start from a point. If we have 2 points, A and B, then use straight edge, we can connect these 2 points. The shape we get, that's called a line segment. This one called a line segment. Or you can call this a segment. And for a line segment, we use this sign to represent. Okay, we add a bar above these 2 points, A, B. That means this one, it's a line segment. Okay, if then these 2 points we'll call the end points. The line segment, they will have 2 end points. Here, that's A and B. Then we use a little tip here, like this, to represent the length of these 2 line segments are equal. So this one, that means xm equals my. And we use this 2 little tip to represent these 2 line segments, zx and wy, are equal. Okay, so here this m called middle point of line segment xy. Okay, start from here. We also need introduce array that's still have 2 endpoints, A and B, but has arrow point to the direction of this array. Then you can say here A we call origin. Okay, that's called origin of this array. And this arrow point to the direction of this array. Then we use AB. Above AB we add a arrow. You can see this. That's called array AB. We use this sign to represent this is array AB. This one tells you the origin point is A. Okay, the direction of this array, that's start from A, point to the B. Okay, this is an array. Now, line that's extended to the two directions, not only one direction like ray. You can say here AB, this is the 2 points. Then we have this line extended to both directions. This one called a line. Then this line AB, we have use a sign AB. Then above we add a double arrow to represent this one's a line. Okay. Then for the line, if we have 3 points on the same line, these 3 points we called collinear points. That means they're all on the same line. Collinear, that means they share a line. Okay? So then we set collinear points. Then these 3 points on the same line. Okay? Then concurrent lines. Concurrent lines, that means the 3 lines, they are intercept at the same point. Okay? Usually this not happen, right? This is a very special case. Usually, even the relationship of 2 lines, they have 2 situations. One is parallel, right? Parallel, that means they will never intercept each other. Another one is their intercept. This is in the 2D. Maybe in the 3D, the situation is more complicated. But for the 3 lines, intercept at the common point, at the same point, this we call that concurrent lines. That means they intercept at the same point. Okay. Then, plane. Plane in geometry, you can imagine this like your computer screen, but extended to the 4 directions. That's left direction, right direction, up and down. So a plane is extended 4 directions. Okay, but they don't have the thickness. Okay, only that boundary. Okay, separate the upper space, lower space, or the left space, right space, but they don't have any thickness. Okay, that's plane. This is a the very basic knowledge what we learn here. Then we can try exercise problems. Now let's say, Royce, can you help me read this first problem? Royce?
So it says Alice is thinking about of a line. How many points on that line does she need to show Bob in order for Bob to know exactly which line she's thinking about?
Do you have any idea about this problem?
Let's say like 1.
Only 1? Why 1? Okay, so that means you can just like this. If Alice try to show this line to Bob, then she just need to set this line A. Is this one right? Okay, Chenri, can you answer this question? Alice need to show how many points on that line?
2.
Why? Yeah, you're right. She need to show 2 points. Okay, this 1 point cannot determine the unique position for a line. If you have this, I can rotated this line, I can go this line, maybe the position can be like this. Okay, only past this point, there's infinite number of lines pass through this one point. Okay, so if you try to determine a line, you need to give 2 points, like here AB. Then this line will totally determined, only this one. This is the unique one, no others. Okay, if you only show the 1 point, then we have infinity number of lines pass through this point. So that's the reason we use a line, we use the 2 letters like AB, then we add a double arrow above these 2 letters to represent a line. Okay? So the correct answer for this problem, that's 2 points. 1 point, that's not good enough. Now let's see. Ellie, can you help me read number 2?
M is the midpoint of line segment AB, and N is the midpoint of line segment BM. If BN equals 4, then what is AB?
Okay. Do you have any idea to solve this problem? So in geometry, I think actually almost for any science or math subjects, first thing you need to draw a diagram. That will help you a lot. So here they tell you M is the middle point of AB. So now let's first draw this line segment. This tells you this is a line segment, right? AB. Now they tell you M is middle point. So now let's suppose M is the middle point. So then we use a little tip here, and here means AM equals MB. Then they tell you N is the middle point of BM. So then you can say, suppose here this one is N. Then you can add another double little tip to represent MN equals MB. N is middle point of BM. Then they tell you BN equals 4. This part equals 4. Then they ask you how long is AB. So Ellie, do you have any answer now?
I think it's 16.
Yes, you're right. See, after you draw this picture, then this problem becomes very, very easy, right? Then you can say they give you BN equals 4. N is middle point of BM. So therefore, BM will equals 8. But M is also middle point of AB. So that means length of AB will equals 8 times 2. That's equals 16. So the answer is 16. But before you draw this diagram, you say this problem actually, if you have long learned the geometry, then it's hard to imagine what is the relationship between these points. After you draw this diagram, the situation becomes very easy, very clearly, right? So then when you try to solve geometry problems, always try to draw a diagram first. Okay. Now let's see number 3. Let's see. Emily, can you help me read this number 3?
P, Q, R, S, and T are on line K, such that Q is the midpoint of PT, R is the midpoint of QT, and S is the midpoint of RT. If PS equals 9, then what is PT?
Okay, same idea. first you need to draw a diagram. Otherwise, this is very confused. Okay, say here, P, Q, R, S, and T are on line K such that Q is the middle point of PT. So now let's suppose here that's P, here that's T. Q is middle point of PT. Okay, Q is here. Then you use a little tip to represent these two parts are equal. That means Q is middle point of PT. And R is the middle point of QT. So that's this one's R. That means here QR equals RT. And S is the middle point of RT. Okay, suppose here that's S. S is middle point of RT. Then they said if PS from here to here, this one equals 9. Then they ask you how long is PT? How long is this 9-segment PT? So Emily, do you have any idea to solve this problem?
Not yet.
Not yet?
Give me a second. I need to think about it.
Yeah, you can. Everybody think about this problem, and if you got your answer, send me a private chat. Now let me see who can solve this problem. You can say idea is start from this shortest segment. Say go backwards. Say S is the middle point of RT, right? Then we can set none of ST that suppose equals X. We don't know that, right? We can set that's X. Then RS also will equals X because S is the middle point of RT, right? Then they tell you R is middle point of QT. So that means QR, this part that will equals 2x. Because RT will equals x plus x equals 2x. Then QR will equals 2x. Let's see. Somebody also send me the answer. Chenry, 72/7. Michelle, 3/4. Definitely that's wrong. And let's continue to do this. Then you can say PQ, that's half of PT, right? So here we already get a QT that's equals 4x, 2x plus 2x. So PQ also will equals 4x. But this way we get you say they give you PS equals 9. PS actually equals 4x plus 2x plus x. So you do 4x plus 2x plus x. This one will equals 9. Then you simplify this, you get a 7x equals 9. So therefore x equals 9/7. Okay? This is a shortest line segment in this graph, right? But then they ask you how long is PT. So you can say PT actually equals 8 times x. Now x equals 7 over 9. So you plug x here, 9 over 7, you get this one equals 72 over 7. Yeah, Chenrui, you're right. The answer is 72 over 7. You can say this problem, it's a geometry problem, but we use algebra way to solve it. Okay? You don't know how long that, you can set that's x, then find the relationship, build an equation, then solve the equation. Right? Okay. So now let's see number 4. Okay, now let's see who can help me read this one. Jessamy, can you help me read this number 4?
Points A, B, C, D, and E are 5 points on a line segment with endpoints A and E. The points are in the order listed above from left to right, such that CD equals AB over 2, BC equals CD over 2, AB equals AE over 2, and AE equals 12. What is the length of AD?
You can say this one have a star. That means this problem is a little bit harder. So the first thing, you still need to draw a diagram first. Say here tell you points A, B, C, D, E are 5 points on line segment with endpoint A and E. So you draw this line. Okay, this one is A. This one is E. Okay. Then they tell you the points are in the order list above from the left to right. So that means the order is A, B, C, D, E, this order. Then they tell you CD equals half of AB. We don't know where is the B, right? Definitely we also don't know where is the CD, how we can draw this. But don't be rush, continue read. BC equals CD over 2. This one still cannot help us, right? Then AB equals AE over 2, and AE equals 12. So they tell us totally AE equals 12. Then AB equals AE over 2. So that means tell you B is the middle point. Okay, suppose B is here. B is middle point of AE. So then you can mark AB actually equals BE. Then you go backwards. Now after you find a B, then you say CD equals AB divided by 2. So this is AB. So then the order, say CD, you can say CD equals half of AB, right? And BC equals half of CD. So suppose C is here, D is here. Okay, suppose D is here. Then you can say CD equals half of AB, and BC equals half of CD. Then they ask you what is the length of AD. They ask you from what is length of this one, AD. So to do this, now you still start from the shortest line segment. So here, let's say they tell you AB equals half of AE, right? So that means B is middle point of AE. Then, and CD equals half of AB. So then you can say we know AE equals 12. Then B is the middle point of AE. So therefore AB equals 6. Then you can say CD equals half of AB. We already know AB equals 6. Therefore, CD that's equals 3. Right? CD is 3. Then they tell us BC equals half of CD. So that means BC equals 1.5 or 3/2. Okay? Then they ask you what is none of AD. So therefore, you can say AD actually equals AB plus BC plus CD. So therefore, AB equals 6, BC equals 3/2, then plus 3. So therefore, you can say this one 1.5, 10.5. Okay, this one's correct answer. Okay, Ellie, you got it? You got a correct answer. Even you're not sure, but then looks your answer is correct. So here, actually, you don't need to know how long is DE. After you draw this picture clearly, then you can say AD actually just equals AB plus BC plus CD. Then we already got AB equals 6, BC equals 3/2, and CD equals 3. Then you add them together, you get the 10.5 or 21/2. Okay, you can see here, this book, why this book is very good. It's very easy to read, and also they emphasize you do it by yourself. Okay, after you learn what is the knowledge you need to solve this problem, then you need to practice use this problem. You can say this problem design is very good. Now every time, then we will give you the homework for the access problems, and for each chapter then we'll have the review problems and also challenge problems. I encourage everybody try to do all of the problems, but if you don't have enough time, at least you need to finish the access problems and the review problems. For the challenge problems, maybe you don't have to do, okay, if you don't have enough time. If you have enough time, I encourage you try to solve all of the problems. Okay, so now let's go to third section, that's round and round. That means we will talk about circle. Okay, so let's see, Michelle, can you help me read this problem 1.1?
Mark a point on a piece of paper and label it O. Use a regular ruler to find points on your paper that are 1 inch away from the point of R. If you draw all of these points, what figure would you create?
What's your answer for this problem? You can say they ask you mark a point on a piece of paper.
Circle.
What?
You would create a circle.
Yes, you're right. So suppose you mark this point, okay, and label it at O, okay. Then you use a ruler to find all the points. Suppose that's 1 inch away from this point, okay, all around this one. What will you draw? That would be a circle, right? So suppose you can draw is like this. All this point, say they will have same distance away from this central point O. Okay, then you get this circle. Okay, so a circle actually it's all the points have the same distance to a central point. Okay, This one called a circle. Now let's see number 2. Royce, can you help me read number 2? Royce, can you read this problem?
The figure shown at right is called a circle.
Continue.
For A, it says, is it possible to draw a line that does not hit the circle on any points?
What's your answer for this? Is it possible to draw a line that does not hit the circle in any points?
I'm not sure.
You're not sure? Okay. Now let's see. Ellie, can you tell me if we can draw a line that does not hit the circle in any point?
No.
You mean your answer is no, it's not possible, or you cannot answer this question?
It's not possible.
It's not possible? Let me show you. How about this? If we draw a line here, this line intersect with this, is this line hit the circle at any point?
No. Not even inside the circle.
If inside the circle, that's not possible. Inside, because this line, based on definition of line, the line will extend it to the 2 directions forever. If you draw here, this called line segment is not line. This line, if it's line, that will be extended to this both direction forever. Even when you first draw, you said, this line segment not hit any point, but because if it's line, then you need to allow this line extended to the 2 direction forever. So definitely they will hit the circle at the 2 points. But if we draw this line outside of the circle like this, then this line will no longer hit the circle at all. So this one is possible. If we draw this line like this line will not hit the circle at any point. So the answer for this one, that's yes. If you do this, you get the line will not hit this circle at any point. Chenri, can you answer the B? Can you read the B first?
Is it possible to draw a line that hits the circle in exactly 1 point?
What's your answer for this?
Yes.
Can you show me how to draw the line? You can draw on my screen. Okay. Yeah. Use a line. Don't use the pencil. You choose pencil that's not straight. Okay. You can choose this straight line. Okay. Yes. Anyway, this one's good. That's right. If you draw a line like this, that's exactly intersect with this circle at 1 point. For this case, we call the tangent. This line tangent. Suppose this one's point T. This line tangent with the circle at point T. Okay? This is called tangent. Ellie, can you tell me C can you draw a line intercept with the hit the circle at 2 points?
Yeah.
Can you show me how to draw that line? Can you draw that on my screen? Very good. You can say this line intersect with this circle at 2 points. We can mark that's like A and B. Okay, you can also use other letters, does not matter. And Annie, can you tell me if we can draw a line intersect with a circle more than 2 points, like 3 and more points?
Is there a point in the middle or no?
No, because circle, you know, that's actually the closed line. For this point, this part, that's not called intercept with a circle. You can only count these 2 points. Okay, this part is not counted as intersection point. That's called inside of the circle. So for what you draw here, this line only hit the circle at 2 points, A and B. The question is, can you draw a line hit the circle more than 2 points? The answer is no. You cannot do that. The maximum hit points, that's 2. That's what you draw here. You say, if you suppose move a line from outside of circle like here, go closer and closer to the circle, the first time you'll be tangent with the circle. Then you will intercept with circle at 2 points. If you move this line keep to the outside of circle, then at one location you only hit the circle at 1 point. After that, then you will never hit the circle anymore. Okay, so therefore the maximum number of hit, that's 2. No more 2. No more 2 points. Okay, so then by this way we finished this section. Now let's go to fourth section, construction. Okay, then you can see here it's a very special part for geometry. Here definitely it's very simple. We ask you copy a segment. So the problem is this. If we give you this segment, line segment, we call this one A, B. Okay, this line segment AB. Then we ask you copy this line segment from here, like to here, or like anywhere. So can you, the 2 you can use, one is compass, another is straight edge. You can only use these 2. Definitely you can use a pencil, okay? Help you to draw a line. So then we are asking you, can you use these 2 tools, copy a line segment from AB, from here to suppose to here? Think how you can do this. Okay, to copy this, then what you need to do, you need mark, suppose first you mark this position as A prime, okay? Then you use a compass. You use a compass, okay? Use this too, okay? Put your 1 foot of compass at A, another foot of compass at B. By this way, you can measure, use the openness of your compass to measure the length of AB. But definitely you don't know how many centimeters or how many meters or whatever the number, you don't know that number, but then you know the the openness of my compass equals the length of this line segment AB. Okay, then you move your compass to here. Put the 1 foot of the compass overlap at the point A prime. Okay, you put that 1 foot on the point A prime. Then you draw a circle. Okay, you draw a circle. Use the center A as A prime. Draw a circle. Okay, suppose you draw a circle here. You draw a circle. Okay, then you use a straight edge. Okay, you can use straight edge. You can draw a line segment. Suppose this one intersect with the circle at B prime. Okay, here the A prime, B prime will be the copy of this line segment AB, right? But then here definitely we don't require you have this one exact direction, right? You can also like what you draw the line segment like this. Okay, so this one, suppose this B double prime. So this A prime B double prime is also its copy of this line segment AB. Okay, that's fine. But later, after we learn the parallel line, then we will maybe require you also need to keep the direction of this line segment. By that way, you need to learn how to get this, keep this angle. Suppose this angle that's 30 degree. We require you also need to keep this angle, but that's the later thing we need to learn. Here, we just need you copy this line segment to another location. We don't care about the direction. Okay, so to do that, use your compass, measure the length of this line segment AB. Then move your compass to point A prime. Use A prime as a center. Draw a circle. Then use a straight edge. Draw a line segment. Intersect with this circle at a point. We call that B prime. Then you connect A prime, B prime. That will be the copy of line segment AB. Okay? So by this way, you can say in the geometry, we ask you to do this. Okay? This is a very different with other subject. You did not learn this kind of thing in other subject. Okay? So say you need to give us the steps, how you do that, and also build this. Okay? But before we do this, you know, we need to have some rules. Okay? What we can do, what we cannot do. In the geometry, we call this called axiom. That's axiom. That means we accept all this as a basic rule we can use, but we don't need to prove that. Actually, you cannot prove that. But then you can use that. Okay? So in the geometry, we have this kind of rules. First, give you a point. You can draw any line through the point. Okay? If we cannot do this, definitely we cannot copy that line segment, right? Just because we suppose if you give us a point, we can draw a line through that point. So even we cannot prove this, but we still can accept this one as a rule. This is called axiom in the geometry. Second one, given the 2 points, you can draw the line that pass through them both. Okay, so that means if we give you the 2 points, A, another point B, you can draw a line pass through these 2 points. Okay, then because it's I did not use a straight edge, so then I can do this. Give you 2 points, then use the straight edge, then you can draw a line pass through these 2 points. Yeah, definitely this one we can accept. Third one, give you a point. You can draw a circle, center at the point. So that means if we give you a point, then you can draw a center, you can draw a circle, use this point as a center. Okay, definitely this one, that's what we can do. The fourth one, given a point at a segment, you can draw a circle that with its center at one point and with the radius equals in the length of the line segment. So that means if we give you a point, give you a line segment, suppose this one is line segment, okay, AB, okay, then this axiom tells you you can use one point as a center, use the length of this line segment as a radius, draw a circle. Okay, yes, definitely this one, that's true. Number 5, if we give you the 2 points, you can draw a circle through one point such that the other point is the center of the circle. So that means this one is similar to the number 4. So this one, that means you can use another point as the center. Use draw a circle, pass through this point. So that means still use this line segment as a radius of your circle to draw a circle. Okay, so this is 5. That's what we accept. We can do, but we don't need to prove that. Then let's see a problem here, 1.3. Let's see. Michelle, can you help me read this problem? Michelle?
Use your compass to find a point y on K such that AB equals xy. You cannot simply use a ruler to measure AB. Then use the measurement to find y.
Can you tell me how to do this? Say they give you this line segment AB, right? They give you this, okay? Then they give you a line K. They mark a point on this line as X. Then they ask you make a line segment on this line called XY. Makes XY equals AB. The 2 you can use, that's only compass and straight edge. How you can do this?
You draw a circle from AB and then do the same on the dot X.
Yeah, I understand. You know how to do it, but you need to describe from the beginning, right? If I do this problem, I'll do this, okay? The first step, I put my compass, 1 foot of my compass on point A, okay? You can write it, put 1 foot of a compass, okay, on point A, okay? Then adjust the openness of the compass, okay, to make it the other foot on point B. Okay. By this way, you actually use the compass measure the length of line segment AB. Okay. Second step, move the compass. Move the compass to point X. Okay. Or you can say put the 1 foot of the compass on point X. Then use the openness. Use the openness as the radius. As the radius, draw a circle. Draw a circle. Draw a circle. Okay, you use X as the center. Use the openness as a radius. Draw a circle. Then the intersection point. The interception points of the circle and the line. Circle and line K at Y and Y prime. Okay, you draw a circle here. Suppose you draw a circle here. Definitely what I draw here is not so good. You draw a circle. Suppose here that's Y. Here that's Y prime. Then you can say XY. That's what we are looking for. XY will equals AB. And XY prime also will equals AB. Okay, that's exactly you need to do. Okay, you need to describe very specific from the beginning how you do this. After another person, any person read your text, then they can follow you to finish this work. Okay, so you can say what I said here. You put the 1 foot of your compass on point A, then you adjust the openness of the compass, make another foot on the compass on point B. Then you move your compass 1 foot on point X, use that openness, draw a circle. This circle intercept with this line K at 2 points. You mark that as Y and Y prime. Then here XY will equals AB. XY prime also equals AB. Right? That's exactly you should do like this way. Okay, now let's see number 4. Ali, can you help me read this problem?
From below are segments AB and MA. Use straight edge and compass to construct the line segment that has length AB plus MA. Reminder, you can't just measure with a ruler. B. Construct a line segment that has length AB minus MA. Even though we don't say with a straight edge and compass, we still can't measure with a ruler. Construct implies straight edge compass in construction.
Okay, do you have any idea to do this? So here they give you this 2 line segment, right? One is AB, another is MA. This one and this one. Actually, they ask you to do 2 things. One is add these 2 line segments. Another one is minus. Okay, first find the sum of these two line segments. Second one is find the subtraction of these two line segments. There are only two. You can use the straight edge and compass. How can you do this? Okay, this actually is very easy. Okay, so how to find the sum? You know, you still use your compass. Put the 1 foot of your compass on point M. Then adjust the openness of your compass. Make another foot is on point N. By this way, your openness that's represent length of MN. Even we don't know exact how long is MN. Then you move your compass 1 foot on point B. Then you draw a circle. Use point B as the center, use the openness as the radius. Okay, you do this. Then you use your straight edge, extend it AB to the direction of B, intercept with circle at point C. Okay, right? We can use a straight edge because we already have 2 points. We can draw the straight line, use a straight edge, then make this line intercept with circle at point C. Then this line segment AC, this one actually is the sum of AB and MN, right? You can say AC that's equals AB plus MN. Because when we draw this circle BC, that's actually the radius of the circle. This radius that's equals length of MN, right? So then if you try to find the AB minus MN, let's say based on what I draw here, Chen Rui, can you tell me how we can find the AB minus MN? Actually, this one we almost already get this one at the same time when we found the sum. You say when we draw this, right? This we can mark this point at D, or you can mark this one at C prime, whatever. So if we mark that one at D, then we can get AD will equals AB minus BD. The BD is the radius. BD actually equals MN. So this one equals AB minus MN, right? So actually we also simultaneously we also get the subtraction of these two line segments. You just need to mark this point as like D or whatever C prime. Then you get this one will equals AB minus MN. Okay, so time is up. We can stop here. Then the homework. Now let's see the homework. That will be. Yeah, actually we already finished this section. Now let's see. We have homework. That's 1.4.1. Only this one problem. Okay, 1.4.1. Okay, so everybody, we can stop here. See you next time. Bye.